Imagine a world unlike anything we have ever known, located far beyond our own solar system, where the possibility of life exists in the vast expanse of space. A distant exoplanet, light years away, where the conditions might be right for life to thrive, and yet we've only just begun to scratch the surface of this new discovery. For years, scientists have speculated about the possibility of life existing beyond Earth, but until now, we've only been able to wonder. That is, until the James Webb Space Telescope, JWST, made a groundbreaking discovery on the exoplanet K2-18b, located about 120 light-years from our home planet. The implications of this discovery are truly awe-inspiring. What we're seeing, thanks to the power of the JWST, is a hint, perhaps even strong evidence, that life, or at least the conditions for life, might not be exclusive to Earth. Could this distant world, K2-18b, hold the key to answering one of humanity's oldest and most profound questions? Are we alone in the universe? The story of K2-18b begins long before the launch of the James Webb Space Telescope. This exoplanet was first discovered by the Hubble Space Telescope many years ago. However, Hubble's capabilities, while groundbreaking in their own right, had limitations when it came to analyzing the atmospheres of distant exoplanets. Hubble could detect the presence of certain chemicals in an exoplanet's atmosphere, but it was unable to provide the level of detail required to make definitive conclusions about the planet's potential to support life. Enter the James Webb Space Telescope, a scientific marvel that has the power to peer into the farthest reaches of space with an unprecedented level of precision. Unlike its predecessor, JWST is equipped with state-of-the-art instruments that allow for highly detailed analysis of distant worlds. Thanks to the JWST, scientists now have access to highly detailed spectrometer data, which has provided them with crucial information about K2-18b. This data reveals that the exoplanet is situated within the habitable zone of its star, a region where conditions are just right for liquid water to exist. Liquid water is one of the key ingredients necessary for life as we know it, and its presence dramatically increases the likelihood that K2-18b could support some form of life. But what makes K2-18b even more fascinating is the fact that it has a hydrogen-rich atmosphere, which opens up a whole new realm of possibilities for scientific study. The discovery of a planet with such a composition raises profound questions about the nature of life elsewhere in the universe. Could K2-18b be a water world, similar to the one Earth is believed to have been billions of years ago, with the right conditions for life to emerge? K2-18b is classified as a high-sea world, a new category of exoplanets that represent water-dominated planets that might actually be more conducive to life than Earth itself. These types of planets are not just oceans with some scattered land masses, they could be rich, tropical environments, possibly teeming with marine life. Scientists have long speculated that planets with vast oceans, and tropical climates, could be far more suitable for life than Earth due to the fact that they are less vulnerable to the changes that we see on our own planet, such as tectonic activity and large-scale volcanic eruptions. For years, these ideas existed mostly in the realm of theory, supported by mathematical models and simulations, but now, thanks to the JWST, we have the first tangible evidence that such planets could indeed exist. The possibility of finding life, or the conditions that could support it, on these water worlds is a reality that we are just beginning to understand. One of the most intriguing aspects of the data gathered from K2-18b is the detection of biomarkers in the planet's atmosphere. Biomarkers are substances or chemical compounds that are typically associated with biological processes. The presence of biomarkers can offer significant clues about the potential for life on other planets, and the discovery of these chemical signatures on K2-18b is a major breakthrough. The most exciting of these biomarkers is methane, a gas that, on Earth, is primarily produced by living organisms. On Earth, methane is often released by microorganisms called methanogens, which thrive in oxygen-free environments such as swamps, bogs, and rice fields. In the digestive tracts of ruminant animals like cattle, sheep, and goats, methane is produced as a byproduct of the decomposition of organic material. Methane is also emitted by termites and other organisms that break down plant matter. Methane is an important biomarker because, while it can be produced by non-biological processes, it tends to persist in the atmosphere for only a short period of time, usually only 2 to 3 years, before it breaks down due to solar radiation. Therefore, the presence of methane in an exoplanet's atmosphere suggests that there must be a continuous source replenishing it. This is particularly intriguing for K2-18b, as it raises the question of what might be producing the methane. While methane has been detected in other parts of the solar system, such as on Saturn's moon Titan, there's no evidence of life there. Titan, after all, is a cold, dark, and inhospitable world where methane is thought to be the product of chemical processes rather than biological ones. On K2-18b, however, the discovery of methane is different. The planet is not a cold, dark world like Titan. It lies within the habitable zone of its star, where conditions are much more favorable for the presence of liquid water. Moreover, K2-18b's atmosphere is hydrogen-rich, and the abundance of methane combined with the possibility of liquid water makes it a much more promising candidate for harboring life. The presence of methane could be a sign of biological activity, with microorganisms or other life forms potentially producing this gas. Scientists are now tasked with determining whether the methane on K2-18b is indeed of biological origin or whether it could be the product of some other process, such as chemical reactions between different gases in the planet's atmosphere. In addition to methane, another intriguing discovery made by the JWST team was the potential presence of dimethyl sulfide, DMS, in K2-18b's atmosphere. DMS is a toxic gas in large quantities, but on Earth, it is primarily produced by biological processes, particularly by certain algae in the oceans. These algae release DMS as a byproduct of their metabolic processes. When DMS is found alongside methane and water, the likelihood of life becomes much greater, as this combination of gases is a strong indicator of biological activity. DMS is typically produced in coastal ecosystems, including salt marshes, mangroves, and other marine habitats where plant and microbial life thrive. The fact that DMS has been detected on K2-18b suggests the possibility of similar biological processes occurring on this distant world. While scientists have not yet confirmed the exact source of the DMS, its presence, along with the methane, paints an increasingly clear picture of a planet that might support some form of life. The combination of water, methane, and dimethyl sulfide is not only a strong indicator of biological activity but also suggests that K2-18b may have ecosystems similar to those found on Earth. If this is the case, it would mean that K2-18b could harbor not just simple microorganisms but possibly more complex forms of life as well. The possibility of finding life on an exoplanet like K2-18b has profound implications for our understanding of the universe. It suggests that life may not be as rare as we once thought, and that the conditions necessary for life to exist might be more common than previously believed. This opens up a new frontier in the search for life beyond Earth, and K2-18b is just the beginning. Further investigations using the JWST will be critical to understanding the full scope of the potential for life on K2-18b. Scientists are eager to conduct more detailed spectroscopic analyses of the planet's atmosphere to uncover additional biomarkers that could offer more definitive proof of biological activity. These future studies could reveal even more specific signatures, such as seasonal changes in methane or DMS levels, which could help scientists determine whether the planet's environment is actively supporting life. One of the most exciting aspects of this research is that we now have the tools to begin identifying possible forms of life on distant worlds, based on the chemical signatures we observe. This type of analysis is still in its early stages, but it holds tremendous promise for the future. In addition to spectroscopic analysis, scientists are also exploring other techniques to study the atmospheres of exoplanets, such as transit photometry. This method involves measuring the tiny changes in a star's light as a planet passes in front of it, allowing scientists to gather information about the planet's atmosphere. These observations could provide important clues about the planet's climate and weather patterns, which could in turn offer insights into biological processes. The more data we gather from exoplanets like K2-18b, the better equipped we will be to answer the big question: could life exist beyond Earth? The James Webb Space Telescope is only the beginning. As our technology advances, we will soon have even more powerful instruments at our disposal. The Extremely Large Telescope, ELT, and the 30-meter telescope, TMT, both of which are currently under construction, will provide even more detailed information about the atmospheres and environments of distant exoplanets. These next-generation observatories will be able to peer even deeper into the atmospheres of planets like K2-18b, allowing us to learn more about their potential to support life. Looking even further into the future, one of the most exciting possibilities is the development of space probes that could be sent directly to these distant worlds. While such missions would take many years, likely decades or even centuries, there is hope that we might one day be able to send probes to planets like K2-18b to study their atmospheres and surfaces up close. Until then, we will continue to study exoplanets like K2-18b through telescopic observations and simulations here on Earth. By recreating the environmental conditions of distant worlds in laboratory settings, scientists will be able to test how life might evolve and survive on planets with different atmospheric and climate conditions. The search for life in the universe is just beginning, and K2-18b is one of many exoplanets that could hold the key to understanding whether we are truly alone. Other promising candidates for life exist, such as TRAPPIST-1e, a planet located in the habitable zone of a red dwarf star. Like K2-18b, TRAPPIST-1e is a world where liquid water could exist, and it has already garnered significant interest from the scientific community. Another exciting prospect is Kepler-186f, an Earth-sized planet in the habitable zone of its star, which could potentially support life as well. With each new discovery, the probability that life exists elsewhere in the universe continues to grow. As we explore these exoplanets and others, one thing is certain: humanity's quest to understand life beyond Earth is only just beginning. Thanks to the incredible power of the James Webb Space Telescope, we are now poised to take the next giant leap in our understanding of the cosmos and the potential for life in distant star systems.